In this presentation, we are going to discuss about the core concept of positional number system. We all know about base 10, that is decimal number system, base 2, that is binary number system, base 8, that is octal number system, base 16, that is hexadecimal number system, and there are many more number system possible. Now let us understand what exactly the base is in a number system. Base is equal to number of symbols we use in that particular number system. And what are the symbols? Symbols are just the pictorial figures to represent the count of items. Say we have this item here, and to represent how many items here, we use a particular pictorial figure and we call this symbol as 1. Similarly, to represent this many items, we use another symbol and this is called 2. Here it is 3 and so on. Similarly, we have 4, 5, 6, 7, 8, 9 to represent that many number of count. Also, we use these alphabets to represent count: A for 10, B for 11, this 12, 13, 14 and 15. And there is another very important number exists, that is called 0 to represent no count. If we have no item, then it is called 0. And in a positional number system, 0 has very importance. So in a particular number system, we have mainly two things. One is the base and the set of symbols. So if it is base 10, we use this set of symbols to represent that many numbers of count. That is, each and every symbol here represents a unique number of count. That is, 1 represent 1 item, this represent 3 items, this 5 items and so on. If it is base 2, that is binary system, we just use these two symbols. This one to represent when we have no item there, that is 0, and there is only one item, we represent this. Similarly, if it is base 8, that is octal system, then we use these 8 symbols. If it is hexadecimal number system, that is base 16, we need 16 symbols there from 0 to 9 and A, B, C, D, E, F to complete 16 symbol. Here also each and every symbol represent a unique number of count, that is A to represent 10, B to represent 11 and F to represent 15. And these numbers, 9 represents 9 count, these symbols 2 represent 2 number of items. Now let us have a closer look to the decimal number system and we will understand how each and every number system works. So in a decimal number system, we use these 10 symbols. Each and every symbols represent a unique count, that is, this symbol 0 represent when we don't have any item, it represents 1 item, it's 2 and so on. So one very important question comes here. We already have completed count up to 9 by using these symbols, but if we want to represent count of 10 item, then how we will represent it, because we don't have any other symbol left. So in that case, what we need to do, we need to reuse these symbols. One thing I must mention here, as it is a decimal number system, each and every symbol used here is called a digit. So instead of symbol, we are going to call this as digit. Now let us come to our question, how we are going to represent number 10 when we already have used all of our digits. Now for representing 10, we are going to reuse our symbol. That is, we are going to use more than one digits there. Till now we were just using only one digit, now we are going to use 2 digit. Here in this position we are going to use 1, and in this position we are going to repeat starting from 0 to 9 again. So our first 2 digit number 10, that represents 10, and next after 0 we write here 1 and this one remains same. So our next 2 digit number we are going to get, that is 11, and that represents count of 11 item. Then 1 2 1 3, that is 12 and 13. Then 1 4 1 5 1 6 1 7 1 8 and 1 9, that is we have counted up to number 19. Then we find that we have exhausted all of the symbols we have with the second digit 1, that is with combination of 1 in the second position we have completed all our symbols. Next, what we are going to do, we are going to use our next symbol in the second position, that is here we are going to use 2, and then again we are going to repeat all of our symbols again in this position, that is starting from 0. Then again we are going to start from 0 with the second digit 2 and we are going to repeat it. So here we get the another number 20, that is 20. Then we repeat 2 1 2 2 2 3 and so on, and up to 2 9. Then we are going to use 3 here and going to repeat all these symbols, and this way we will reach when both the digits in first and second position reaches 9, that is we have completed all our symbols with 2-digit combination. And after that, what we are going to do, we are going to introduce 3-digit number. Till now we have completed all combination with 2 digits. Now we are going to introduce a 3-digit number with the third digit as 1, and the other two thing we will start from our starting symbol, that is 0. Now this is the first 3-digit number we are going to get, and we call this as 100. And then again when we will exhaust all the combination of 3 digits, then we will be introducing another digit, that is a 4-digit number. Here we will write 4 and all other 3 digits will be 0, and this first 4-digit number we will be called as 1000. And we will be repeating the same procedure, and it is possible to count up to infinity. Now let us move to the starting portion and observe a very crucial thing. Let us very carefully focus on the transition points, that is when we are moving from 1-digit number to 2-digit number and from 2-digit number to 3-digit number. There we are going to get a very interesting thing. Here we have moved from 1 digit to 2 digit, and the second digit is 1. Why it is 1? What exactly this single digit, this particular digit represents? This second digit represents how many tens we have, because just before this 2-digit number we have completed count of 10 numbers including 0. So each and every digit in second position represents how many tens we have. Now let us focus on this number. When we change the second digit from 1 to 2, first we have found out that the second digit represents how many tens we have. So here in this number we have 2 tens. So here by using multiplication we get 2 times 10 is equal to 20, and that is how this number 20 is formed. As we have found out the second digit represents how many tens we have, similarly the first digit represents how many ones we have. For this number 14 we have 1 10 and 4 1, that is 1 into 10 plus 4 into 1, and that is how we are going to get 14. Now let us move to the 3-digit transition point. Here the third digit represents how many hundreds we have. Why? Because when we have reached 100 here, till then we have counted up to 99, and including 0 we have counted 100 numbers. That is, after completion of 100 numbers count, we need to introduce the third digit, and that is why the third digit represents how many hundreds we have. So for this number we have 100, 0, 10 and 0, 1. So that is 1 into 100 is equal to 100. And similarly, the fourth digit represents how many thousand we have. So in decimal number system, the first digit represents how many 1 we have, the second digit represents how many tens we have, the third digit represents how many hundred we have, and the fourth digit represents how many thousand we have, and so on. Now let us take few examples of decimal numbers and check how their value is calculated. So here we have taken a 3-digit number. As we know, the third digit represents how many hundreds we have. So here the third digit is 2, so we have 200. We write 2 into 100. Then as we know, the second digit represents how many tens we have. So here the second digit is 4, so we have 410 here. We write 4 into 10. And as we know, the first digit represents how many ones we have. So here the first digit is 7, so we have 7 1. We write it like this, and then we are going to add them up. So after doing calculation, we get 200 plus 40 plus 7, and finally 247. Now let us observe a very important and crucial thing in this calculation. This particular expression can be written differently. Here, instead of writing 2 into 100, we can write 2 into 10 into 10, and that can be converted to 2 into 10 power 2. Similarly, we can write this particular expression like this: 4 into 10 power 1, and this can be written as 7 into 10 power 0, because 10 power 0 is equal to 1. Here we are dealing with base 10 number system. So here let us observe the behavior of the base value here in this expression. Here, as base is equal to 10, so we have multiplied with each of these digit the base value with a particular power to calculate the value of this particular number. If we assign sequence to each of these digits of a particular number from right to left and starting from 0 onwards, then here in this example the rightmost digit is 7, that is the first digit, and we have added sequence 0 to this, and so we are multiplying here 10 power 0. And similarly here 4, the second digit, gets sequence value as 1, and then we are multiplying 10 power 1 with it. And similarly the third digit, here we have assigned sequence as 2, and then we are multiplying 10 power 2 with the third digit. And this is how the base value and the position of digits becomes important in positional Radix based number system. Hope in this presentation I have successfully delivered the core concept about number system. So I request you, please write the expression for this special number in the comment section to calculate its value. If you really feel this video is helpful, please like it and don't forget to subscribe my channel.